Hello everybody, my name is Jacob Domingues and this is my charge tape revisited lab. All this lab is a comparison between two computational models of an object being suspended due to an electrical force. My hypothesis was that these different models will be similar, but they'll contain different values due to differences in their actual setup. The two physics principles that are the basis for these computational models are Coulomb's law and Newton's second law. Coulomb's law is talking about the electrical force due to charge on an object, and Newton's second law just talks about motion due to forces. So what's actually happening in this lab? 2 weeks ago, the first part of this lab, there was an experiment run to hover a tape, sort of like a bridge, and then take another similar tape under it. Both tapes are charged same way, so they'll repel, and put the other tape under it, so it'll sort of suspend it in the air, measure that distance, and then use it to see how it's being suspended, how much charge is on the tape. Taking all that data, we put it into an ideal sort of coding environment, use point charges to calculate that amount of charge. This week, we created another computational model, but this time we're using line charges instead of point charges like we did the week before. And this will alter sort of how much charge is needed to suspend the tape. So this was the first computational model where we just had 2 point charges. That's what it looks like. And here's all the code for it. The way I did this was I just took some initial conditions you see on the left, basically set up all the charges, the tapes, so they'll actually run, do some R manipulation, like R hat, R mag, and then put it into the electric field equation here, and then use that multiplied by charge to get the force. And then down here we use Newton's second law to create motion to make sure that it's not moving. Here's the second computational model. You can see we have a bunch of different points that are acting sort of like a line. The left is the first week's code, and the right is the second week's code. Obviously, a lot more code for this one, but sort of the same principles. Set up a bunch of initial conditions and initialize the tapes, get them ready to be iterated on. Do an electric field function. This time, I actually use the def function to make e field its sort of own defined function. And then this time we used a for loop kind of thing to iterate that charge at each point across, each point dx across the line, so infinitesimally small, but in this case it's just n small, 1 over n, and calculate the electric field at that point. So my results, obviously we got very different Qs here, but my Q for this one was 4.03301 times 10 to the negative 7, very small amount of charge. Obviously the difference in these suspensions is, or the difference in the setup, where versus like a point charge versus a line charge, is what we're changed the required charge necessary to suspend it in the air. And I think this is because we have a lot more charges, all with Y components, that push up on the top tape, the DQ. So my system is the hanging tape, and my surroundings will be gravities from Earth and the bottom tape pushing up. And how do we calculate the charge? Well, basically, I knew that there was no acceleration, so sum of forces equals 0. So I set gravity equal to that electric force, and then when all of this was set up in the thing, in the coding, I could just manually sort of solve for Q and find a value for Q that would make this the sum of forces 0, 0, 0, and that would suspend the top tape perfectly. So what if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge, blah, 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 blah. Basically, if I were to change to a point charge again and use the charge that I got in this lab, the charge in this lab is much greater than the one that I found in the point charge lab. So this would make a system where the electric force on the bottom is greater than the force of gravity, so it would push up on the top tape, and it would go into the air more. So why do these estimates differ? Which value is likely to be closer than real life, and why? These charges differ because there's more going on in the line model. The line model has 2n, which is how many sort of like line charge iterations we're doing. 2n electric fields pushing up and being pushed, while the point charge only has 2. Or not electric fields, that should be 2n sort of points that are being pushed up. But there are also 2n electric fields in our thing, which is a lot more happening. Like, you can imagine that very left side point on the top tape is being pushed up still by that very right bottom tape point. It has a smaller component of Y than the one directly below it, but it's still being pushed up by it. So that's probably why there's a difference. This difference correlates with the lower Q value, like I said, and there's less charge due to the fact that there are more electric fields pushing up the charge, like I said. Okay. I assume that this line charge would be closer to the actual value because the line model is a lot more similar to the tape's physical geometry. And yeah, thank you very much.